In this video, I'm going to work through solving a couple of equations using my equation solving flowchart. So we'll try and work through all these questions one by one, go through the process, and use that to solve our equation. Here's the first equation we're going to work with, 2 parentheses x plus 4 all over 3 minus 8 equal to 32. So our first question on the equation solving flowchart is, can you use the distributive property? Well, when you see parentheses, that's usually a dead giveaway. Yes, you can use the distributive property. I'm going to distribute 2 times x and 2 times 4. That's going to give me 2x plus 8 in the numerator. And I still have 3 in the denominator. All of that minus 8 equals 32. But I'm not done with the distributive property just yet. I'm going to use the distributive property to clear the fractions out of this equation. So I see that denominator 3. I'm going to distribute a 3 on the left-hand side. And whatever I do on the left, I also have to do on the right. So I'm going to also distribute a 3. The nice thing about distributing a 3 to this fraction that has a 3 in the denominator is cancels out the 3. In my classes, I talk about how these things kind of Candy Crush away. It's like lining up just the right things on Candy Crush, and they just go away. So the 3 and the 3 cancel out, leaving just the numerator 2x plus 8. Now, the distributive property also tells me I have to multiply that 3 times the negative 8, and that gives me negative 24. On this side, I have to multiply the 3 times the 32, and it gives me an output of 96. So I now have an equation that doesn't have fractions, which I'd much prefer to the equation that originally did have a fraction. Let's see where we are on the equation solving flowchart. We've done the distributive property, kind of used it double duty. Now let's go to the next box. Can we combine any like terms? The answer is yes. I see a positive 8 and a negative 24. I can combine those like terms to get a negative 16. So I see 2x minus 16 equals 96. I go back to the flowchart. Ask myself, are there variable terms on both sides of the equal sign? The answer to that one is no. I only see variables on the left side, not on the right. So move on to the next box. Is a number being added or subtracted on the same side as the variable term? And that is a yes. I'm going to move up here to continue the problem. We see 2x, and then we see the number 16 being subtracted on the variable side. To deal with that 16, I have to undo it. I have to line up a positive 16 underneath of it, a plus 16 underneath here, and a plus 16 underneath this 96. That's going to allow me to Candy Crush this negative 16 and positive 16 away. They cancel each other out, and down drops a 2x. 96 plus 16 comes out to 112. And back to our equation solving flowchart. Is a variable being multiplied or divided by any number? Yes, it's being multiplied by a 2. So we are going to use the inverse operation. We're going to divide by 2 to cancel out that 2. Again, it just kind of Candy Crushes away. It's gone, leaving x isolated. That was my goal. And on the other side, 112 divided by 2 gives me 56. All right, now there's a try it problem. Go ahead and pause the video and you can try the next problem yourself. And now I'll show you how that second problem works. First question is, can we use the distributive property? Well, it's not quite so obvious as it was in the first one. We're not going to use the distributive property like we did with the 2 times the x plus 4, but we are going to use the distributive property to clear that fraction. So I'm going to write 4 plus 3x minus 1 over 2. And I'm going to put that in a parentheses, and I'm going to distribute a 2, hoping to cancel that denominator out. So we're distributing a 2 on the left side. Of course, whatever I do on the left side, I'm going to have to do the same on the right side. So I'm going to take that 9, and I'm going to also multiply it times 2. As we distribute, 2 times 4, that's an easy one, 8. And 2 times this fraction, well, yeah, that's the reason I did this, was so that the 2 can cancel out that denominator of 2. So I just wind up with plus 3x minus 1. Two times 9 is 18, and we're up to another box in the equation solving flowchart. Can we combine like terms? Yes. I see some like terms that I can combine. I can combine this positive 8 and this negative 1. Those can combine to a positive 7. I can either write 7 plus 3x or 3x plus 7. Doesn't matter which. I'll do 3x plus 7. And that is equal to 18. Now there's a number being added on the same side as the variable term. So I'm going to subtract 7 from both sides to clear that. Minus 7 on this side, minus 7 on this side. Now I have 3x equal to 11. And finally, I need to divide both sides by 3. I'll come up here and do that. 3x equals 11. Divide both sides by 3. To undo the multiplication, and we'll be done. X is equal to the fraction 11 over 3.